Hello, dear listeners. Thank you for tuning in. My name is Bill Wirtz. I'm a senior policy analyst at the Consumer Choice Center. I am joined by Dr. Kanniah Rajasekaran. Rajasekaran. I'm sorry, I'm butchering your name, but he's a research biologist at the U.S. Department of Agriculture, and he's specialized on the issue of mycotoxins. First of all, Doctor, thank you for joining us today.
Thank you, Bill. I'm extremely pleased to discuss with you about the importance of mycotoxins.
Thank you. So first of all, let's dive into this issue. Mycotoxins, it sounds like a complicated medical term, but so what exactly are we talking about here? What are mycotoxins and what do they mean for consumers?
Mycotoxins is myco refers to fungus. So any toxin produced by the fungus is actually called mycotoxin. And there is almost several millions of fungal species. Out of that, maybe only 70 to 100,000 have been studied very carefully. And of that, there are small section of the fungal species that are actually toxin producing. That's what we are going to talk about today.
Yeah, so there's a wide array of different types of mycotoxins. Can you just lead us through which ones are problematic for human health and do they affect animals? Like what exactly are their effects? What do they constitute?
In fact, only very few fungal species that produce toxins are of importance to us because they are the ones causing a lot of damage to the human health as of today. If I have to name the top three, it'll be the first one will be Aspergillus species, and the second one will be Fusarium species, and the third one is probably Penicillium. And but we work on controlling the Aspergillus fungus, which produces aflatoxins. Aflatoxins is nothing but a subsection of mycotoxins, AFLA, that is Aspergillus flavus toxin. So aflatoxin. So that's how it is got the name. And this is one of the most dangerous, naturally produced dangerous carcinogenic compound. It is so dangerous. The International Agency for Cancer Research, it's a global body, IARC, has labeled this as a group 1 carcinogen, which is the highest level it can give to any chemical. So this is actually really dangerous. If consumed in large quantities, the acute toxicity results in liver cancer, and in small quantities, it can actually create a lot of other problems like stunting in children, learning disability, that kind of stuff. So we need to be careful not to have this problem permeate through our food supply. But unfortunately, it is not so in several countries where this is not being monitored properly. In all the developed countries, it is being monitored. In fact, the export regulations dictate that they cannot accept more than certain level, depending on the country. So that's being taken care of really well. But in African countries, in Asian countries, this is a big problem. And unfortunately, several people have actually lost their lives because of this toxin.
You say it's a problem that's larger in less developed countries. Can you give us a perspective on how prevalent this problem is in the United States, and then to compare it with other countries? Like how prevalent is this
Well,
problem?
let me say address this in a different way. What are the crops that are most susceptible for this problem, even including in the United States? Corn, one of the major food crops in the United States, is susceptible. Cotton, although it's not a food crop, the cotton seed is processed as an animal feed, so that's another crop. Then peanuts or groundnuts, as they call it in Asia, that's also highly susceptible to this problem. So we are trying to address a lot of means to control this fungus before it reaches the consumer table. So I hope to discuss with you on that also.
Yeah, it's a wide array of products. Now, give us a sense of how do mycotoxins develop in these crops? Like, how does it how does that just naturally occur in all crops, or is there a climate related issue as well?
Well, you hit all the nails right there. In fact, it is a naturally occurring problem, but this problem get exacerbated because of drought conditions. Whenever there is a severe drought or a lack of water and high levels of carbon dioxide, which is another manifestation of the climate change, these all can actually change how bad this problem can be. It can be so bad in U.S. corn industry alone. It expected the projected loss of this problem is up to $1.5 billion a year. So that's what the projection is. But on an average, we do see anywhere from 300 to $900 million of loss. This is crop loss only. So if you include the mitigation efforts, the human cost, the health costs, and all that, the costs actually add up quite a bit.
And what examples of health consequences can you give for large consumptions? You mentioned it's carcinogenic. What cancers can it cause, and what other health problems as well?
Well, the Aspergillus fungus itself, when it produces lots of spores, people can inhale these spores, especially in immunocompromised people. This can actually go and dislodge in their lungs, and it causes aspergillosis. That is the name of the disease. But the toxic effect is actually the toxin itself, the toxin aflatoxin produced by this fungus, when in acute doses, can actually cause liver cancer. And sometimes, like I mentioned, in smaller doses, it can cause stunting in children and learning disability and all that thing. But I'm talking about only the Aspergillus fungus now. But the other major one is actually the fumonisin, which is a mycotoxin produced by the fusarium fungus, which infects more like corn, wheat, barley, grain, sorghum, all these crops. And this toxin is well known to cause throat cancer, the esophageal cancer. So ARS scientists have studied these for a long time, as well as the university scientists. So these are the two major ones, but of course there are a lot of minor ones called trichothecenes and DON, which is deoxyribonucleic, otherwise known as vomitoxin. It actually creates vomiting. So we study only controlling aflatoxin in our group. There are other ARS groups that are actually studying the toxins produced by the fusarium fungus, which is fumonisin, and they study trichothecenes and other toxins as well.
You mentioned that it's climate specific, but it is still widespread. Does climate change affect the prevalence of mycotoxin contamination?
Yes, unfortunately, the increasing levels of carbon dioxide and the sudden change in temperature. I'm not talking about 1 or 2 days or a month-to-month variation, but if there is a shift in the maximum temperature, even by 1 degree Celsius, this is what we call global warming. This fungus can actually infect in an area which is beyond its normal habitat. So it can move up to, say, the northern states of the country. And even in Europe, there has been well documented that a slight change in temperature and water availability and carbon dioxide levels can cause a lot of damage with this increasing climate effects.
So let's bring this to a personal consumption level for people to understand. We here in Europe, we've observed this a recent study by the University of Copenhagen that found that that a large amount of consumers think that the fact that product has mold shows that it's natural, and that that even leads to the belief that the consumption of these products after they had mold is safe. can you speak to this feeling? Do you understand? Like, can you give us a feeling where this comes from? These ideas of consumers, and speak to the dangers of these ideas.
I can actually talk from a personal perspective, and because I'm a plant scientist, so I actually study how to develop resistance to these fungal species in plants. But I'm also I'm directing a group which is working on these fungal toxins also. So we know a lot about the fungus also. So like you said, yes, I agree. There are a lot of naturally occurring fungal species. They are good species. They actually degrade a lot of things that we don't want to see in nature, and they can produce a lot of enzymes that the industries make use of for several industrial purposes. And even cheese, some of the cheese that we consume, they are actually produced because of this fungal infection, some good fungal infection. But we have to caution that even among plants, although all the plants are actually really useful to humankind, there are some plants which are extremely toxic. Even if you eat 1 or 2 berries of these plants, you can actually die on the spot. Like that, in fungus also, most of the fungal species are probably good. And I can understand where the reference is coming from. But some fungal species like Aspergillus, Fusarium, when they infect the crops, the fungus themselves may not be toxic. If you say you accidentally ate something that is infected with the fungal mass, that may not be toxic. But when the fungus starts producing the toxins and that toxin gets contaminated the food supply, they become really a big problem. Like I mentioned to you, aflatoxins are extremely toxic. The level is actually the regulation, the international regulation, at least I shouldn't talk about international. The US makes sure that the level does not exceed 4 nanogram per gram. That is, 1 nanogram is actually 1 billionth of a gram. So that is 4 nanogram per gram. In milk and all that, it is still lower, up below, not more than 2 nanogram per gram. In other words, it can be a microgram per kilogram, which is one, I'm saying this in nanogram per gram so that you can relate to the toxic effect of these compounds. So the main aspect of this is actually, it's extremely toxic even at a lower level. That's what we need to concentrate on.
Now, you mentioned it's naturally occurring, but the way I understood it, it can also arise as a bigger problem through bad food storage. So what importance does food storage play in this context?
That's a good point. Of course, aflatoxins can actually contaminate the field crops. So when we harvest, the grains are already contaminated because the fungus invaded the seeds and it produces the toxin. This is what we call a pre-harvest contamination. Then even if you harvest clean crop from the field and store it in unsafe conditions, meaning higher humidity, higher temperature, unclean conditions, this fungus can actually start infecting stored grain material also. So the reason why we are working on both, we need to control pre-harvest contamination and we need to control post-harvest storage also. Only then the dietary intake from these grains will be safe to eat. There are many ways of controlling these things. Of course, there are a lot of experts in all these areas. Hopefully, we can get into that also later.
Yes, absolutely. We will get to that. Now, about the storage, when it comes to retailers. So I spend a lot of time during the summer in Turkey, and I saw very often that in supermarkets, you would have the fruits and vegetables outside, and they would be in the sun at 33 degrees Celsius. Does that constitute a problem? Does this create a similar problem, or is this not an issue?
If you're mentioning about the temperature, maybe that is not the sole criteria for saying that these are vulnerable for aflatoxin contamination. But if we store them in a high temperature, high humidity, this is actually an ideal condition for the fungus to grow, any fungus, including Aspergillus or Fumonisin, and they can actually take over the storage lot and then actually produce a lot of toxins. So I won't, say only the temperature is a major thing, but there's a combination of things: unsafe, unclean conditions or storage conditions.
When it comes to marmalade, how does that work? Sometimes I've seen in a marmalade that wasn't closed correctly, you see the mold on top of it. There again, my grandmother would say just cut it off and then eat the rest. How does that? Is it the same there?
My marmalade jar, that's one of my favorite ones also, but unfortunately if you leave it longer out in the open for this is a way of attracting, even if a single spore lands on a sugary marmalade or any other jam or something, they will start growing. But if you see a lot of them on this spot, you can cut it away. People do that all the time, but the thing is, you don't want to consume when there is an overgrowth of this fungal material on the jars inside or on top of the jam itself or the marmalade. I wouldn't recommend it. It is unsafe to eat anything that is totally infected by unknown fungus at this point. So we want to make sure that people don't eat by mistake. This is a fungal infection. It's a good fungus or a bad fungus. You don't know that. If you know that, that's well and good. But if you do, you have to act accordingly to discard that thing.
Now let's come to the issue of what tools farmers are using to prevent mycotoxin contamination. What products do they use? What methods do they use?
We are trying to deal with this in 3 different ways. Number one, one is actually controlling the fungus itself, the fungus that occurs in soil, which I'm going to label it as a biological control. When microbiologists or fungal mycologists go and look at the fields, they can sample the Aspergillus species, for example, and there are almost several species that do not produce this toxin, and some they do. So we need to encourage the non-toxin producing strains to grow at the expense of the toxin producing one. That is the whole concept of biological control. That was developed in our institute right here, and now it has been applied to a lot of cotton growing areas in Arizona, corn growing areas in Texas, and peanut growing areas in the southeastern states. And this technology has been exported overseas also. In fact, there are 35 or 36 countries are using this technology as of today, with a lot of financial support from Gates Foundation, the African Union, and Europe has a big program to control these toxins also. And our scientists are working with people in South America, South American governments, Mexico, Pakistan, Australia, all these places. This technology is being applied to control using the biological control mechanism. So the biological control is one of these better way of dealing with it, but then again, it's not 100% control. Even if you get 80 or 90% control, the toxin level that remains on the crop can still be toxic. So we need to look at other mechanism of control also. So we need to jump to other methods where we can transfer the genes very quickly from a resistant line to a susceptible line. That's where the transgenic mechanism comes in. In fact, this is highly regulated, as you know. We can identify a gene resistant in corn or even other plant species. then we can move that gene into corn or cotton or peanuts, and we can actually develop resistance this way. And and the third mechanism is actually by studying the fungus itself, how this fungus actually gets to make toxin, at what stage. Although we don't understand the whole scope of why the fungus makes the toxin, we can actually identify the fungal genes that are actually triggering the aflatoxin production. And in our unit, we actually deciphered the whole pathway to make aflatoxin by the fungus. So we can actually target those fungal genes and make them ineffective in producing the toxin. How do we do that? We actually enamel the corn plants, empower the corn plants with a gene construct that will actually target the fungal genes. When the fungus invades corn or cottonseed or peanuts, they can actually target this one or two fungal genes only at the RNA level. RNA level meaning it does, so it will degrade that RNA so the fungus cannot make toxin. This is what's called a host-induced gene silencing mechanism. This co-host meaning host plants, they actually silence the fungal genes in either Aspergillus or Fusarium or any other toxin-producing fungi. And they can actually do that without producing any foreign protein in the plant, because it's done at the RNA level. So RNA gets degraded, that is actually ephemeral, it disappears. And this goes on, it cycles through and keeps continuously operating in the plant so that the fungus cannot make toxin, or it won't. Some of the genes, if we target, they will not let even the fungus grow inside the plant. So that's what we are doing. So all these mechanisms are in place. And of course, the most basic practice is, how to control it on the field. Farmers have been very knowledgeable to do this. When do you water? When do you control the drought condition? How do you control it? Or can you do kind of an application of any other technology, even using mild dose of fungicides? All these things can be useful in controlling a severe toxic problem, but the longer time-consuming research is actually all those. Biological control is effective, as we know. Producing breeding is time-consuming, but we can actually hasten that by producing transferring genes between places, and we can target the fungal genes themselves by the silencing mechanism, which has been proven very promising in our lab, and we will be testing some of those corn lines very soon out in the field after getting permits from APHIS.
Well, thank you so much for taking the time to explain to our listeners the implications, the methods, and the scientific background that governs this problem. Thank you so much. Thank you. To our listeners, thank you for listening in. If you want to continue to follow our work, obviously you find us at consumerchoicecenter.org and continuing our work in agriculture, especially as we see ongoing reforms in Europe and interesting developments and new scientific innovations in the United States. Thank you again, and have a nice day.